Okay, guys, so let's just wrap up a little bit and do some review of the first unit. So the way I think about this course is we want to understand how we get to understand the brain, and then we move on to all the things that we understand, or, well, the first of many things that we understand. Um, Now, Unit 1 is really about how we come to know what we know in cognitive neuroscience. And I think of it as an overview um, of all the methods and also some of the history. And there's a little bit of neuroanatomical background as well, but just kind of more the basics, more the guidelines about how we think about where things are in the brain than about individual regions themselves. So this is an overview of the topics we've covered so far. We started by talking about the history of the field, and then we went a little bit into neuroanatomy, and then there's a couple of days on structural neuroimaging, how we come to look into gray matter and white matter, and then also functional neuroimaging, and that's kind of the bulk of cognitive neuroscience work right now. And so there's a variety of techniques that we use to better understand the brain. And then neuropsychology, that's just a short little section there, but really looking at people with um, with disorders and trying to relate their behavior to understanding the brain. And then perturbation methods, we've just covered that today. Now, there's always a lot of questions about neuroanatomy, which is how much do we need to know? Do we need to know everything, everything, like every single map of the brain? Well, the answer is no. You don't need to know every single map of the brain, but anything on the slides would be good to know. Parts of the neuron, right, that are pretty basic in neuroscience, are good to know. There's some basic neurofunctions that you do need to know about, right? We talked a little bit about action potentials and circuits and how they form. We talked about directions and how we find our way around, how we navigate within brain space. Right? So terms that we use to locate different areas of brain, that's very important. We also talked about this distinction between gray and white matter and how they're distributed in the brain and how they're distributed in the spinal cord, and the central and peripheral nervous systems and how they're generally oriented. And then we talked about the major brain areas and at the level of the cortex. And we talked about the major landmarks of the brain, so sulci and gyri, and what those mean, and where the major sulci and gyri are. Then we talked about ventricular systems, right? So you need to think about how the ventricles are all interconnected in this neural tube. And then the vascular system, you need to know, what the names of the major arteries are, and how they're connected together, and what damage to the major vasculature might look like, and what that might mean. Then um, then we spent a lot of time on structural neuroimaging, by first going into kind of the quick and dirty dissections, or very detailed work on dissections. And then we looked into X-rays and how that works, and CT scans, and how that's just a three-dimensional version of X-rays. And then we spent the bulk of the time on magnetic resonance imaging. You need to know the difference between a T1 image and a T2 image, right? So how you can tell those apart, and you need to know how a diffusion tensor image is different from T1 images in particular, and what that's useful for. Then we spent quite a lot of time on functional neuroimaging. It's a really important unit, starting with single unit reportings and ECOG, right? So actually going into the brain and doing more invasive reporting and specific groups of cells. And we talked about EEG, MEG, and how those work, and a few different ways to analyze EEG and MEG data. And then we talked about PET scans, which is important for understanding metabolism. And we spent a good amount of time on functional MRI, and I should say that that is still the most commonly used technique within cognitive neuroscience, I think. I would say fMRI and EEG together are the most commonly used right now. Then we talked a little bit about optical imaging, not much at all, but it's just really good to know like a little bit about how it works and why, when it's good, when it's useful. Then the section on neuropsychology is relatively short. You need to know the components of a neurological exam, right? So if there's a neurological patient in a ward, right, what are the general kinds of things that you might do to test their behavior, without actually ordering an MRI scan or any kind of scan. Right? Then you don't need to know all the names of the cranial nerves, but you need to know in general what cranial nerves are, and if there's a major kind of damage, you should know about it. And then we talked about lesion overlap and BLSM techniques to relate lesions to behavior and symptoms. And then finally, today we talked about perturbation methods. You need to know the logic behind why we do perturbation methods. And then TMS and TDCS are the two major classes of methods that we covered. So I can end by an exercise question. As you might have seen from the exercise midterm practice questions that I've posted so far, the test is going to be 50% multiple choice and 50% free responses. Right? And the free responses are pretty short, so they will have a component of that's writing, and you should be guided by the number of points that are allocated, which are clearly indicated on the exam. That should tell you how much I expect you to write, right? So if a test question, a free response question, if it's just for 2 points, right, then I just expect relatively little information. If it's for 8 points, then I would expect relatively more information. And the amount of space that I allocate on the test paper should give you some indication of that as well. So these free response questions can range from pretty specific ones, like tell me these 2 things, to pretty vague or open-ended, hopefully not too vague, but relatively open-ended types of questions. So, how does the brain enable intelligence? Design an experiment to test some aspect of this question. And so that's a pretty open-ended question, right? So I'm asking something that's quite hard to answer, but I want you to think through the design process of an experiment. And I'll try to be as clear as I can be about the what I expect. Right? So in your experiment, please describe your specific research question, what your hypothesis is, who your subjects are, what your test subjects would do, and what methods you use and why, and describe expected results and what they might mean. Right? So this is one of these, I think it's almost a free giveaway in a way, as long as what you're saying is logical and well argued, and you actually read the question and answer all the components of the question, you should be able to do pretty well. But you are graded for kind of your logical flow, right? So if you say something like, "I'm interested in imaging intelligent people's brains and looking at their brains with good spatial accuracy using EEG," well, then that's wrong because you don't get very good spatial accuracy with EEG, right? So it has to be kind of internally consistent. But other than that, it can be quite open-ended, and creativity certainly helps. Okay, good luck.